Creo PTC by Engineer Lewis. I'll hand over to him to take us through advanced surface modeling using Creo PTC. Thank you, Engineer Lewis. You can proceed.
Thank you. Welcome today. In our session today, I'm going to model one part, and I'm going to use the most uh, recommended technique of modeling any design. Whenever we get a part, we have to do drawings, and someone says, "Can you model this part for me using any CAD tool?" There are so many techniques there outside. But the technique I'm going to teach you today is the best ever technique. Remember, the car your design is about is how robust is your design. How how easy is your design? How easy can someone change your design? I'm going to use this part. This these drawings I got them from website from SolidWorks website called Model Mania. If you go to Model Mania, it is a competition usually organized by SolidWorks each year. They started 2000, and the part I want to model is this part of 2002, which is a bit interesting. You see the reason why. And if you want to get the drawings for this part, if you scroll down, it has two sessions. I'm going to focus on the first session here. And if you open those drawings, these are the drawings I'm going to use. You're supposed to model this part, and I'm going to model this in Creo live today. I took a screenshot because I don't want to switch back to the website. Yeah, I have opened an empty part in Creo, and I'm going to start with a new. Let me just open it. I'm going to start with a new part. Call it SW2002 part. It is a part. I'm using millimeters today. You can change the units as per your preference, but I'm going to use millimeters. Then let's now start to understand the technique we're going to model this part. If you view this part from this view here, you can see this part has overall width is 70 and overall is length is 100 here by 70, and we need to understand this, not overall, from here, from the center, apology, from this point here to this point is 100, and this one is 70, and this one here is like a cylinder that is of 70 length, and the diameter of this cylinder is given by 70 plus an offset here. How you are going to model this, the first sketch is very important. It's very important, and that's the reason why I said let's use this part and show you the best technique. Therefore, as you can see on this view, I like starting the view that has a lot of dimensions. We have these two center lines here, and there's this one here, center line. Therefore, it means we model one side, then we mirror to get to the other side. From this view, you can see if you model this half and mirror, you get the bottom side. Therefore, let's start to capture these initial dimensions. Okay, I'm going to start with the onto which plane. I can start with the top plane because I'm going to start with the top plane because when you view from this direction, this is what I want to see. I can start with the top plane. I can start with the front plane, but yeah, let me go with the front plane because this one is the front. Let me start the front plane. If I go front, sketch, I need now to capture these center lines. First, these center lines, I'm going to capture them. Center line here. This one is there by default. Another one here. And the center line, I'm going to put this one in another screen, but I put it here in case I want to explain something. Here is 100 from dimensions, because our circle passes here. You can see the dimensions. Our circle is 70 inside here with an offset of 70. Therefore, if I create 70 there, like that, then let me first for dimension this. Is 70 and 7. Outside is 70, inner 70, here 70, but here and from here is 7. That is 7. Okay. Next is we have now this one here. That is you can see this line is tapered. This line is tapered here. To continue, let's first create that line. The tangent to this and tapered. Let's first create tangency here, because we and we know the angle is 15. Let's capture the angle here from here. Use 15. But now we do not know the termination, where it is terminating at. Okay. Okay. Let's now go back to this view. It will help us to know where this line is going to terminate, because when we elongate this, we want to know at which point does this line terminate. We don't know this point. If now let's start to look for those dimensions. If I go back now to this view here, I can see the center line here is continuous, but there's this 7 here. You see that 7? Meaning, if assuming there's no draft angle of 7, therefore, if I put a straight line, I know now where my line terminates. It terminates at a point whereby it is this circle of 15. If I offset 7, I'll get this point. Basically, I'm looking for that point, that is from this edge here to that point 7. Therefore, what I'm going to do, I know at this point where the 100, at this axis, I have my circle of 15, like that. Let me first of all give this for construction, because I'm defining this one here, this circle, like that. But we don't have it in this direction, the reason why it's a construction line. And I know if I drop line and go back to there, somewhere there, this 7, where it terminates, I cannot dimension it from this point to this point to be 7. Just from this line to the circle here, dimension from this here to this to be 7. This 7, I was able to get it from here, this 7 here, from this edge of the circle. And now I can trim. This one I should have used it all the way continuous from there to there. Then I can trim this direction, another line here, like that. I cannot trim this bottom side. I can trim here, and my sketch is fully defined. Notice there's something I'm going to skip at one step. I wanted to illustrate to you. I'll skip it so that you can understand that step. But now we have captured all the dimensions we need. Everything is captured. That's the sketch one. Okay, and we can now extrude. I like using a surface. For me, I'm a fan of surfacing, and I want to cap edges like that. I have captured this view. Which view? This one here. I've captured that without a draft. Therefore, if you view from this side, that is what you have captured without draft. Next, we go now to the top view to capture this now. Let's now understand. We have this a circle of 15, the one I used as my reference, and we have these straight lines. For now, you know the draft angle, these straight lines. Therefore, we are going to model from top, sketch. First of all, I want to reference this line and this line, like that. You can select reference all these lines. I need not create a line first there, but I don't know where this line terminates. You can mirror this line, by the way, onto this, like that. But now we go back to the design, to them here. Let's now look for those dimensions. I have this 15, and I know this is offset of 7. Therefore, if I was able to see my now if I was able to see my initial circle, the one I used, remember the sketch I created here. Remember there's a circle that was here, but now it is hidden. Now, this is where we are saying about now how you make your model intelligent. I'm going to do like this. This circle, I created a circle here on my first sketch. Therefore, if I'm able to connect these two, if you connect these two circles, when you control one of them, everything else is going to change. Therefore, I'm going to connect this to this. Okay? Therefore, I'll go back. How do I connect that? I'll go back to this sketch here. Because this one is for construction, if you change it to be, uh, if you change it to be non-construction here, the sketch is not no is no longer a complete loop. Can you see? When you see this one means complete loop. When you don't see this something. I can use what I call points. You see these points here? There's this point here, 2 points. This and this. This one here and this one here, we have different work. This is a sketch point, sketch entity. It exists inside the sketch, but this one here is a data point. Therefore, if you select a point and attach it onto this circle like that, I can now view, I can be able, I get two axes. Can you see? These are these two axes I got here because I have introduced 2 points here. Therefore, if I change this diameter here, 15, my point is going to change. Okay, if I go back now to this sketch here, like that, I have now my point here and point here. And I know the center is here. Therefore, if I create, now I can create my circle and touch those 2 points. And another circle that is tangent to this outer one. And I'm confident these two are 7 millimeters. Can see reference. They are 7 because this 7 is being driven from the first sketch. Always make sure you connect your sketches to ensure that your model is robust. I have connected sketch 1 to sketch 2. If in case I change sketch 1, sketch 2 will always change. Therefore, then I need now to connect this and this tangent, this and this, like that. Then I can now do a trim, like that. And my sketch, I have not used any dimension. Remember, if you want to use this, I'm teaching you the best practices whenever you are designing. Avoid over-dimensioning your design. Avoid repetition. As you can see, my second sketch, I have not dimensioned anything because sketch 1 is controlling everything. This one is called master sketch. You can give it maybe a master sketch, or you can say main sketch that controls everything else, even extrude. Okay, now I have my sketch 2 here, but sketch 2, there's something else I want to teach you. Avoid avoid this technique whereby you bury something inside a sketch. Instead of having a circle here, just make it for construction. You don't need to bury it. Okay, I I prefer just create this extrude, then that circle create it separately. Avoid buried features. You want to bury an extrude cut inside a sketch. Most people, that's what they do. They sketch something here, they put holes here. Avoid this technique. It's not good. Don't bury things inside a sketch. If you sketch now here, I can use a surface like that. Something else I want to tell you. Now, my my surface here, I'm using surfacing today. I'm not using anything like a solid body. Now this dimension here, avoid using dimensions arbitrarily. Some people they say extrude this by 100 and continue. Why 100? What happens when this main sketch changes? When I come here and change the main sketch to be bigger than 100, will I go back here? Do I go back to extrude 2 and change this value? Avoid this. Remember, avoid using unnecessary dimensions. The best technique now, I'm going to go back. I'll go back to my main sketch. Remember my main sketch? I just need to know the maximum. What is the maximum of my sketch? I am going to create a center line at this point. That's the maximum. And put a point there. It's a point already existing. When I say okay, when I go back to my extrude 2, I can now use this point to reference that point. Now I'm confident that in the case my first sketch was to change, anything was to change, my extrude 2 will always change. You see how I'm connecting everything else to the main sketch. I'm controlling everything from one source. From one sketch, you control everything else downwards. Okay, I've not used any dimension. We can test this. Let's do a test here. Let's change something. Instead of 70, let's make it 80. You see my extrude 2 is changing. I'm not using an arbitrary value of 100. No, that is not good technique to use when you're designing. Now I cannot trim. I can merge this and this and get that shape. This shape is the one I was looking at from top view. I have now this shape here. I have this shape now. I have how many features? Extrude, sketch, extrude, and merge. I have not used any dimension anywhere. I'm referencing the main sketch. Now, remember the hole that was here. I said avoid merge putting the hole inside. Because sometimes if you're designing a component that is going to be manufactured by injection molding, especially plastic design, you want to put a draft in that hole. When you bury that hole inside the feature, it will be very difficult to put a draft. Therefore, I have these 2 points that are very important. And if you want to change, if you want to move anything, let me first of all sketch that hole. This one here. This. Some people prefer to bury it. For me, I like using the best technique. This circle, I don't need dimension. Fully defined. Fully defined already. Extrude. I go to extrude. Now a surface. Go remember how we said don't put a dimension to reference my point. I'm using this point because it is the maximum point in our the maximum. Okay. Then merge this to this. And let me change the direction here like that. I get my hole. You see? I get my hole there. And the funny thing, this hole, I'm controlling this hole from main sketch. If I want to change the size of this hole, where do you go? You go to the main sketch here, this 15. If you want to make it 5, it becomes 5. I'm not controlling this extrude. I'm going back to the main sketch. Assume we have 1,000 features down the line. All of them, they are going to change from one point of control. Therefore, that is what I'm insisting today. You don't always make sure that your design are referencing one point. Avoid all those a lot of references. If you give someone this design now, tell them, can you modify something? You just go to the main sketch and change something. And my design is now very robust. Okay. Now we need to apply what? Now this internal cutout. This one here. There are several ways you can achieve that, but today I'm going to show you just one of the ways. Now let's now understand this. These are this cutout here, and it is this one here, like that. That's what we need to get, and we are seeing it is an offset of 7. We have an offset of 7 here. We have an offset of 7. That is what we need to create. You can see this one is 14, meaning 7, 7. If you convert this to a solid, those people who prefer solid modeling, you can just use a shell. When you shell that, you create that automatically. If you do 7 here, you see, shell, and you get it. But for me, I'm not using solid. I will say today is an advanced surfacing. Let me show you how you can create that using a surface. I'm going to utilize whatever I have. I'm going to take this, copy paste, control V, control paste. Okay, I'll get a new surface here. And let me just give it some appearance. This is that surface, red. This is the main surface. This is the surface I'm going now to use to help me create that cutout. And I know we need to have a thickness of 4. There's a base 4 here. Therefore, what I'm going to do is offset this surface here. Offset this surface by 4 opposite. Opposite by 4. Okay? I got a new surface here. Okay? Whatever I'm doing, it can be done by shell automatically. Assuming you don't have a shell command and you want to use surfacing, this is how you go about it. You see something here, you're getting this hole. Okay, if you don't want to get this hole, what do? Just take the hole like that, move the hole. It, it has disappeared. That is in case you don't want your surface to have a hole there. Therefore, now we have this surface here. Now we need to define this a sketch that is 7 mm away. I'll go back to the top view like that and avoid referencing a child. Always go to the foundation. If you're building a house, you always reference the ground. Therefore, in the case you want to design something, don't reference the top edge. Reference the ground edge because this can change. This can change. Someone can put a round, a fillet, but the ground one will never change. Therefore, I'm going to reference the ground. Therefore, reference the ground one by selecting this edge there and that one there. Then top, then reference that edge. Okay. Then from there, I can create my line there. That point, that point like that. Then I prefer utilizing symmetry. So select this one here, mirror it to this line here, like that. And you get those two lines there. You need to dimension them. I'll show you how to dimension them in a proper way. Then you need not to offset this. Remember, it is from 7 away. Therefore, you can now offset this. I can create a circle here using this here like that. And this and this, they have to connect like that. Then change this to 7 away. Now, we have all these dimensions. You need to eliminate all these dimensions. You don't need them. How are you going to go about it? That's 7. Remember, this 7 here, this one here. We have used it somewhere else. Remember when we used it here? Whenever you see a dimension that is being repeated here, when you design, don't repeat. When you repeat, you're making a mistake because if you want to change that dimension, you have to change all the places you have repeated. Okay, my sketch is here and I'll show you the best way to go about it. Therefore, I'm going to create a line here like that. Then I know this. Remember that my reference here and this are supposed to be parallel. Then I create another line. I can use this there. If these two lines are equal, I'm going to lose several dimensions. I lose several dimensions now. You can see. Therefore, if I dimension this line to be 7, I still have this dimension here. Okay, let me see this one here. What is happening? Okay, it is this line not connected. Let's connect this line. I have this 7, but now I need to eliminate this 7. I need to eliminate it. How can I eliminate it? Simple. You can see when I change this dimension, this circle is changing. This circle is supposed to be concentric to this one here. I just reference this, delete this one here, then this and this equal. Make them equal. I have another sketch, no dimension. I'm not dimensioning anything in my sketches. Yeah, I'm just referencing, so that when you change something on top, nothing is going to break down the tree. Things break when you start dimensioning, when you perform double dimensioning. Lastly is about that. My sketch is fully defined. There's no sketch. There's no dimension in my sketch. And I can now extrude my sketch to create a surface up to, remember this depth, don't add a value, reference a point, like that, a surface. like that. Let me now hide my main, okay? And let me hide this, like that. I can now merge these two to create this is what I need. You see what I need? That. If I go back now here, with this one here, I have used wrong surface. I have used wrong surface there. I'm supposed to use the other one, the inner one here. Let me just hide this. I'm supposed to use this. Yeah. I need top side, top section. Yeah. That is what I need. You see the top section? So that I can use this top section to extract from the main. Now I can merge those two and get from the main. Let's preview and get similar thing. Why have I used this technique? Why have I not used a solid technique? This is the reason why I've used this technique. If I go back, let us go back all the way there. If I say solidify, if I use shell, you see this dimension here. This, you have to put a dimension there. And I'm avoiding dimensioning things. If I say shell this surface here, I'm putting a dimension and I have no control of that dimension. It is inside, it is here. Okay, that's the reason why I have not used this method, because that dimension is buried inside the part. If I want to change anything, I just go to my main sketch there. If you move things around here, things, if you make this, for example, make it 20, okay, this one here make it 65, okay, maybe make it 80, like that, okay, nothing, nothing breaks. You see, that is the power of using the technique I'm teaching you today. Lastly, let me just go back to where it was, 15, 70, yeah, 15, okay. You notice here, we have made a mistake here. If I go to view and section view, a section here and see, okay, you see, we made a cutout from our main surface here. This cutout is not supposed to be there. If you go back now, let's see where we made a mistake. If you now merge and merge again, okay, I see. We are not supposed to cut there. Therefore, the sketch we made, the sketch we made here, the one we used to extrude, if you go back to that sketch, we are supposed to reference this line. I use this, we are supposed to reference this line, not this. Therefore, change reference, simple, change reference, use a new line there, delete, done. Simple. Okay, still cutting it. And go back there. Okay. Okay. Yeah. But you get the point. The point is avoid barring, avoid barring the any dimension things inside a feature. Then just figure out how to fix this from the side. It's about the sketch, but once you draft it, you'll see. Just figure out from the side, save some time. If you now go back here, now this one here, for you to get the bottom side, you need to mirror this. If you select mirror, I'm going to use, okay, let me just select this one here, right click. If you select mirror onto this plane, you get to the bottom side, like that. But there's a problem. Who can spot the problem? If you try to merge these two, you cannot merge. You cannot merge, you see. Feature failed to regenerate. Choose OK to create a failed feature or cancel. Say OK. Just create it here. Let it fail. Just create it. But now, how do you fix this? Whenever you are merging two surface bodies, assuming you're merging this surface to another surface here, you should not have two surfaces that are touching. It will never merge. Two cannot touch. Therefore, we go back one step, back here, and we need to remove this surface. Remove that surface and leave open. Leave an opening there so that when now you mirror, you don't have two surfaces that are touching, then your feature is going to generate properly like that. Okay, and later you can add your rounds if you want, like that. Okay, like that. I have skipped draft intentionally, because yeah, you can try that on your side to apply a draft. Yeah, it's a simple one, and also figure out how to fix this here on your side. Okay, which is this offset. Remember the offset we used here, 7? Yeah, it fixes. It's about offset. It's gone. That step has been gone. You see now, I did that intentionally for you to see the mistake of burying when you bury a dimension inside. Because this offset was supposed to be 7, but I used 4, like that. Okay? Remember, there's supposed to be 7 here. You can see here, 14, 7, 7 here. This is when happens when you bury a dimension inside. To avoid this, you always go to tools and create a relation.
Ushamaliza, unajua huku ni streaming yangu imekatika online ama umeanzia?
Now, that is how you can do. You can create a model in the best way possible. I hope you have learned something today. And if you want to learn more about good techniques, reach out to us and we are going to organize a session for you. Thank you.